Hello everyone, this is the introduction to our course of Wlan driver programming. So in this lecture actually we are just going to identify what are the different components present in our Wlan architecture. Basically the Wlan architecture, what exactly is present in user space, what exactly is present in kernel space, and how it interacts with the actual hardware. So the motive behind this lecture is like to understand what we are going to cover in our main course. So this is just a overview of the full course and what are the programming we need to do, what languages we need to know before starting this. So I'll start with that. So to know about the Dublin devices, basically if you can take device which are there in your home, basically some routers or technically we call it as access points. So there are differences between routers and access point. So but as of now we'll consider the router, home router, whatever present there. In if we talk in terms of WLAN, we call it as access point with few major differences. So coming to the components, so if you see the slide, so basically we'll start from the bottom. You have the wireless device, which is basically your chip. Your chip is present on a board which we call as embedded board. So and there are so the chip can be from various vendors. For example, like Qualcomm will be providing their chip, MediaTek will be providing their chip, Broadcom will be providing their chip. So it depends on the cost and depends on the stability. uh, different vendors will be using different chips. So if we talk about the industry, there are like few companies who will be making the chip. For example, Qualcomm, Broadcom, these are the companies which will be making the chip, and they'll be giving initial code base for that. And again there is a diversion in that, like the code base, they'll be releasing one open source and they'll be releasing one proprietary. So whatever boards are available in the market, most of them will be having open source driver for them as well. So how to how as a so I'm treating like this course is basically for the beginners who just want to enter the WLAN. So for that we just need to understand what are the various components present in it. So we'll start with the Qualcomm or MTK or any driver. Basically these are the bottom layer drivers which will be doing few things, like suppose if you put any chip onto the board, the first thing what it will do is like it will try to identify whether that chip has been activated or not. Okay, on once the chip is activated, it needs to perform certain functions to make it available for the operating system. Basically we call it as registration. So whenever the Qualcomm chip, suppose it is present, so this Qualcomm chip needs to be enabled in the device tree of the kernel. So when the kernel boots up, so kernel will find, okay, I found one chip which is a Qualcomm chip. Now Qualcomm chip, in the starting it will register itself with the kernel. So registration with the kernel means kernel is aware of the chip, and we can use kernel file operations and other operations which are supported by the kernel to access that particular device. So this is this part of accessing the kernel and accessing the device memory regions, and initialization of the interrupts, initialization of TX and RX data path. These all things are done in the bottom layer, which I have mentioned here is like QCA slash ath. Basically the meaning of this is like QCA is Qualcomm Atheros, and Qualcomm Atheros open source driver component is basically ath 9k, ath 10k, ath 11k. Like ath 10k is for 11AC, ath 11k is for 11AX, so like that. So similarly for MediaTek, so MediaTek will be using various chipsets and their like a few of them is like MT7621, 7618. So various versions will be there, and likewise there will be other vendor specific, for example Broadcom will also be having a similar layer. So now coming to the uh, like now we'll move a little bit up. So whenever a driver is initialized, one part which WLAN driver take cares of is like it will get registered with the MAC 802.11, and MAC 802.11 will get registered to CFG 802.11. Now CFG 802.11 is having the capability by which user space app can access the driver using netlink sockets. So they have actually built some library called libnl, and through libnl uh, utilities like IWinfo, they'll be able to communicate to the CFG and then to the Mac, and Mac will actually Mac has the capability to configure the driver as well. So this is basically the full flow. So as you can see, like kernel space, in kernel space CFG 802.11, Mac 802.11, and the vendor specific drivers are basically present. Okay, now coming to the user space app. So user space app, they are having like two major components: host APD and supplicant. So if we are in AP mode, you can say as of now AP mode is something like it is like a hotspot by which multiple station means any mobile, laptop, anything can get connected to it and get internet. So whenever a chip is in AP mode, that means host APD should be running in it. So host APD is the guy who is responsible to make the board in AP mode, whereas supplicant is the guy who is responsible for making the board in station mode. Station means there are many station means if you are using any phone or laptop, in that supplicant will be running, and in the home routers host APD will be running. So these are the daemons which will be controlling many things, like for example it will be having their own state machine, it will be managing all management packets, it will be receiving events from CFG, and based on those events it will be taking some action. For example, like if a client wants to roam, so before roaming CFG will be sending some event like, okay, my current RSSI is low, so I need to roam. So the main roaming is basically triggered by the supplicant. So this is how the flow will be there. So this is just an overview, we'll get into details about everything. Now next is like the user utility IWinfo WLAN config. So IWinfo is basically open source, which you can find anywhere, and these are specific to lib 802.11, NL 802.11, and WLAN config is a command which is specific to Qualcomm proprietary driver. So Qualcomm basically, as I said, like Qualcomm will be releasing two drivers, one is like open source, one will be their proprietary. So if you use Qualcomm proprietary driver that is basically based on QSDK, so they have a command called WLAN config. And I have mentioned another thing called agent. So agent, now I'll explain how this WLAN systems are used in the industry. So ideally, as I mentioned, like chip manufacturing companies are like Qualcomm and Broadcom, but there are many companies which will be using their chip, building their software on top of it, and selling it to the customers, like companies like Reliance Jio, companies like HFCL. They'll be doing the same thing. So what they'll do is like they'll take a basic driver from Qualcomm, from Broadcom, from any vendor. On top of that driver they'll be building their own layers which will be proprietary to their like proprietary features of their own. So now in today's world, what is the most important thing? Most important thing is like communication with the driver along with communication to the cloud. So they'll be building one agent on the user space which basically communicates with the bottom layer, and it sends the events or whatever is required to the cloud. And cloud, based on certain things, they can take some action and they can it has a capability to react also. It will be sending some command like, okay, now based on this statistics, I feel like this action needs to be done. So cloud basically takes that action. Now clouds pushes some command, the agent will be handling those commands, and finally the agent will be pushing those commands to the CFG, which is getting set to the driver, and driver is in a optimized mode, you can say. For example, like if there is a channel congestion in channel 6, so normal user won't be knowing like there is a channel congestion. So in today's analytics, what is happening, agent is basically receiving the channel stats, it is sending to the cloud basically evaluates like, okay, this channel is busy, so they'll be sending information like you can switch the channel to 11. So it will be pushing to the agent will be pushing to the drivers, and driver will be changing the channel. So this will help in increasing the throughput. User experience will definitely improve by this. So this is basically the full architecture what we are going to cover in our course. So in this there are various things, various you can say various mechanism that we are going to use. For example, for user space and kernel space communication, we are going to use libnl library. We are going to use IOCTLs, which are most commonly used for getting and setting anything in the driver. Then we are going to use some proc fs entry. We can see like how the kernel double and related parameters can be pushed to the proxys file system, and we can that can help us in debugging many issues. So and yeah, and slowly we'll get into the CFG 80211. So we'll try to write our own commands which will be setting the channel whatever we want. Then will be trying to understand like how Mac is getting registered with the CFG, and how the QCA independent drivers are getting registered with the Mac. So we are going to understand the full flow, and along with it the add-on for this course is like, so suppose think like this, there is an embedded board. So to boot a board you need U-boot, you need kernel, you need file system. So you cannot build everything separately. So in industry there are many, they'll be using many build systems for this kind of thing. One of the build system name is OpenWRT, which is widely used in the networking industry. So if you go to any Cisco, Broadcom, Qualcomm, everybody will be using OpenWRT. And the point I was mentioning, like Qualcomm will be having their own proprietary driver. That proprietary driver is also based on OpenWRT only. So in OpenWRT we'll be learning how to add a package, how to add a kernel module, and with the help of those things we'll try to create an image. That image can be flashed to any board, and that is a final image that industry will also release to their ODMs. So ODMs will be putting those images into the whole bunch of devices, and they'll be going to the customers. So these are all components that we are going to see in the lecture. So I think yeah, that's all for now. Thank you.